Okay. So in this lecture, we are going to do some points that we've left while doing the Legendre's polynomial, unfortunately. So what I'll do is I'm going to just list a few points. I'm not going to derive them up, but I'm just going to uh, leave you with certain, you can say, facts so that you can remember it for your examination. I think for physics students, no such derivation is required. However, I'll try to give you some idea to it. But overall, these are all those points which were left out in the teaching of the Legendre's polynomial. Okay. So let us first begin with one of the concept that is called as singular points. Okay, so at times you'll find in exam also, and otherwise it should have been done, but unfortunately, as I told that because of certain reasons, I forgot to tell you all those things. So let us just focus on the first concept. So I'll write some important points regarding Legendre's polynomial. Regarding Legendre's polynomials, which unfortunately I forgot to mention somewhere. So all those points which I forgot to mention, I'm going to mention it here, and you can take them as a fact also. And anyway, the derivation is not required as such, but you can take them as facts. So some of the points which were actually left out while I was teaching you all. So the first point that happens to be the case is the discussion on ordinary point of the singular point. So ordinary point and singular. So this we'll probably do in detail if the time allows, and if I was ever able to do the power series solution method. But if that's not the case, let me just explain you a little bit so that at least if some question around this comes in examination, then things can be done. Okay, so you know that your Legendre's polynomial is given by 1 minus x square d2y upon dx2 minus 2x dy by dx plus n into n plus 1 y equals to 0. So this is something called as your Legendre's polynomial. If I divide this entire equation by 1 minus x square, so your d2x upon dy square minus 2x upon 1 minus of x square dy by dx plus n into n plus 1 y divided by 1 minus of x square equals to what it will come out as 0. Okay, is that clear? ये चीज समझ में आ गई? ठीक है, मैंने सिर्फ 1 minus x square को डिवाइड किया, कुछ भी नहीं किया.
Yes, sir.
Okay, so you can see that this particular thing, like for example, if you see that there is a like I have divided by 1 minus x square. So this points, if I see that this particular thing will not be defined at x equal to plus minus, you can see that this particular function will not be defined at x equal to plus minus. Okay. So if I have I'll just give you an example. So if I have a differential equation, differential equation given by I'll write it here. If I have a differential equation, let's say given by a naught y double dash x plus a1 x y dash plus a2 x y equal to 0, and this I can write a1 x upon a naught x y double dash and a2 x divided by a naught x y equal to 0. So all those points where your a naught x becomes 0, all those points where your a naught x becomes 0. So points where a naught x becomes 0 are called as singular points. Okay. Further, to check that whether they are then there is something called as regular singular point and irregular singular points. I'll write it somewhere. The points are classified into two categories. The singular points are then characterized into two categories. One is called as regular singular point. I mean these sometimes in exam मतलब इस तरीके के क्वेश्चन पूछे जा सकते हैं. So that is why I'm just doing it for that sake. The points are called as irregular singular points. So let us again take an example of, like, I'll take this only. So your a naught y double dash plus a1 y dash plus a2 y equal to 0. Okay, and let us say that uh, uh, a1 upon a naught यहाँ पे आ जाएगा y dash, and then there would be y double dash, and then this would be a naught upon a2 upon a naught y equal to 0. And let us say x equals to a is a singular point. मान लेते हैं x equal to a is a singular point. Singular point मतलब समझ पा रहे हो, जहां पर a naught 0 जाए. X equal to a is a singular point. ठीक है. So if x minus a into a1x upon a naught x and x minus a का whole square into a2x divided by a naught x are analytic at x equal to a. Analytic मतलब ये differentiable are analytic at x equal to a, then x equal to a is called as a regular singular point. Then it is called as the regular singular point, otherwise irregular. Is that clear? And
Yes,
a
sir.
point is called as an ordinary point or regular point. A point is called regular or ordinary point if these functions, that is a1x upon a naught x and a2x upon a naught x are analytic at that. Are analytic at that. Is that clear, Bharat? These are just definitions.
Yes.
So पहली चीज सिंगुलर पॉइंट निकालने का तरीका क्या है? जस्ट डिवाइड दिस, लाइक अगर इसका कोई कोफिशिएंट है d2 जो हाईएस्ट डिग्री तुम्हारे पास डिफरेंट डेरिवेटिव है उसका कोफिशिएंट डिवाइड कर दो, एंड at the point x equal to plus minus 1 you have a singular point. You can see that x equal to plus minus 1 you have a singular point, isn't it?
Yes, sir.
Okay. Okay. So here this and this particular singular point x equal to plus minus 1 is a regular singular point. You can see that you can multiply this by 1 minus x square. This 1 minus x square would get cancelled. So this is some, this will give you a like finite limit, and here also you'll get a finite limit. So overall this x equal to plus minus 1 are singular points, regular singular points for Legendre's polynomial. Is that clear?
Yes, sir.
Okay. Okay. And if one asks that where do you think that your solution would diverge? Where do you think that your solution would diverge? So where do you think your solution would diverge? Your solution would diverge at x equal to plus minus. Clearly. So for example, if I have this Legendre's differential equation, that is d2y upon 1 minus x squared d2y upon dx2 minus 2x, you have this dy upon dx, and then I had, I think, plus n into n plus 1 y equal to 0. If I divide this by 1 minus x square, so clearly my solutions would diverge because of the divergence of this thing. Because here at x equal to plus minus 1, this is not defined. So my solutions would diverge at x equal to plus minus 1. So therefore, you should understand that we write a solution for mod x less than 1 because we don't want to incorporate x equal to plus minus. Is that clear? And since you can say that x equal to 0 is an ordinary point दिख रहा है? देखो यहाँ x equal to 0 रखोगे तो defined है, x equal to 0 रखोगे तो ये भी defined है. X equal to 0 clearly is an ordinary point. So therefore we select a power series centered at x equal to 0 as a solution. Centered at x equal to 0 as a solution, as a series solution. तो ये सब चीजें मतलब सीरीज सोल्यूशन में पढ़ाई जाती हैं बच्चों को डिफरेंशियल इक्वेशन में. जस्ट आई वांटेड टू मेंशन, सो आई मेंशन. सो ये चीज याद रखना, यहाँ पे x equal to plus minus 1 are regular singular points, and therefore we do not want to take these points. So we take x का mod less than equal to 1, and x equal to 0 is an ordinary point. Why an ordinary point? Because here you can see that both of these expressions are well defined at x equal to 0. They are analytic at x equal to 0. So therefore we select, whenever we want to find the solution, we select this as a power series, that is ak x ki power k. Probably if I'll get time someday, I'll solve these things. But this is like all these things are done in traditional MSc courses, so I don't want to do it. But someday, if time allows, I'll do it for you. Okay, is that clear? This is one of the facts that I wanted to tell. Fact number 2 that you should remember, and that is good enough to understand. You might have seen different orders of Legendre polynomial, and one thing that you would instantly note that all the roots of P and X, all the roots of P and X equal to 0. One, they are real. Second, they lie between -1 and +1. They lie between -1 and +1. And third, they are always distinct. That you can see, एक दो examples से. Okay. So all the roots of P and X equal to 0. Obviously, P naught यहाँ पे नहीं आएगा. So P naught क्योंकि P naught 1 होता है. So your P1X is 1. So देखो ऐसा बनेगा इसका ग्राफ. Your P2X is 3x square minus 1/2. तो इसका quadratic graph बन जाएगा. Your P3X is 5x cube minus 3x/2. तो एक तो x equal to 0 आएगा, एक नेगेटिव रूट आती है इसके, एक पॉजिटिव रूट आती है. सो आई थिंक दिस इज हाउ इट विल बी. ऐसा कुछ आएगा. And all these roots you will find that they are coming between -1 and +1. So this is P3x, this is P2x, this is P1x. Is that clear? इसको याद रखना पड़ेगा because इसका जो derivation है, it will invoke Rolle's theorem and all. Probably I can actually help you with this, that the roots will lie between -1 and 1, but distinct roots I will have to again take a long derivation. So just remember that all the roots of P and X would be real. They will always lie between -1 and 1, and all of them would be distinct roots. Matlab they cannot be repeated. So you cannot have repeated roots of P and X equal to 0. Is that clear?
Yes, sir. P0x will also be there, sir.
Obviously, P0x, there would be no logic in doing that, because P0x then 1 equal to 0. So that does not make sense. So here I'm saying for n greater than equal to 1. Is that clear?
Okay, sir.
Okay. Similarly, another fact that you should remember is that in any case, -1 to +1, P and X dx would be 0 except n equal to 0. Because at n equal to 0, you will find that integral would be equals to what? I think 1/2. If you see, no, 2. देखने एक बार check करो इसको.
Yes, sir.
Okay. Now here you would be surprised. You will say no, only if x was odd, then it is the case. No, at even also you'll find that this integration would become 0. At even also you'll find that this integral would become 0. Is that clear or not clear?
Yes, sir.
Probably I may help you with this. इसको तो मैं थोड़ा सा try कर सकते हैं. Let us try this. एक बार try करके देखते हैं. Try using Rodrigues formula. Try using. देखो इसको भी try करने को कर सकते हैं, but this will invoke Rolle's theorem, and then मतलब एक बहुत लंबी derivation है. मतलब बहुत लंबी तो नहीं, but still it will take time. So I want to finish things off. So just remember it as a concept that all the root of Legendre polynomial are real. They always lie between -1 and +1, and they are distinct. Okay, and now try using Rodrigues formula. Try using, Rodrigues formula. So what is your Rodrigues formula? So Rodrigues formula for deriving P and X is 1 upon 2 की power n factorial. I think this is dn upon dxn x square minus 1 की power n. Is that clear? Now if I integrate it, so it will become -1 to +1. I think 1 upon 2 की power n I can take out, n factorial I can take out, and this is dn x square minus 1. Okay, is that clear? So this will be like 1 upon 2 की power n factorial. This will be equivalent to writing, if I integrate this, this will be like dn minus 1 upon dx minus 1 x square, or I'll write x minus 1 की power n into x plus 1 की power n from -1 to +1. Is that clear?
Yes, sir.
Okay, and here is the power n, and if I differentiate it n minus 1 times, so obviously there would be a residual of x minus 1. So let us say if I differentiate this and if I don't differentiate this, so obviously at x equal to 1 this will go to 0, and at x equal to minus 1 this will go to 0. Is that clear? देखो मैंने
Yes, sir.
सिखाया था, तो मैं वो एक फॉर्मूला सिखाया था, लिबनिट्ज फॉर्मूला, जिसमें क्या करते थे, ऐसा कुछ करते थे डी, अगर मुझे nth डेरिवेटिव निकालना था, व्हाट आई यूज्ड टू डू, समेशन r equal to 0 to n ncr dn minus r, and then there was a function, and then dr, whatever was the function. So for example, if I want to take this n minus 1, like cr, so obviously if I want to, like, there would be bracket which will contain x minus 1, because if I want to differentiate it, मतलब तुम समझ पा रहे हो, मतलब अगर ये जैसे x minus 1 का होल स्क्वायर है और तुम उसको एक ही बार डिफरेंशिएट कर रहे हो, तो ऑब्वियसली बात है कि x minus 1 बचा रह जाएगा. सो दिस इज n minus 1, दिस इज n. सो ऑब्वियसली मतलब in this expansion you'll always find that there are terms in x minus 1, and then there are terms in x plus 1. So if I place 1 there, so it will become 0. If I place minus 1, it will become 0. So always remember this is 0 except n equal to 0, because at n equal to 0 this integration would be 2. Is that clear? याद रहेगी चीज? ठीक है, मतलब बच्चे जनरली क्या कंफ्यूज होते हैं कि इवन के लिए 0 क्यों हो गया, इवन के लिए 0 क्यों नहीं होगा, इवन के लिए आपको बस इतना बोला गया है कि इंटीग्रेशन इसके बराबर होगा, ये थोड़ी बोला गया कि 0 नहीं हो सकता. So if you know the property correctly, minus 1 to 1 f of x dx, this integration would be equal to 2 times integration 0 to 1 f of x dx. It can be 0, but certainly fx is odd, then it is 0. That is very certain. That is very certain. ठीक है, इसका मतलब ये नहीं कि इवन हो जाएगा तो 0 नहीं हो सकता. It can be 0 there. Is that clear or not clear?
Yes, sir.
Okay, good enough. Now another fact that you can write. I think that we were trying one day to derive that also, but somehow we could not derive it. Before that, let us do a few more facts thing. बस ये factual चीज है, मतलब जिसको तुम्हें याद रख लेना चाहिए, so that your life becomes easy in your exam. So another factual thing is, I think a few of them I have already done. एक factual चीज और लिख लो. Let us say what will be the value of, let us try to understand what will be the value of, I think P2 and 0 it should be. Just give me a minute. Okay. What should be the value of, I'll write here. Another fact, this is fact number 3, this is fact number 4, that one needs to remember. So this is P2n plus 1 0, it is always equal to 0. So P2n plus 1 0 is always equal to 0. So how would I do that? What should I use? Let us use, so दो चीजें हमेशा याद रखो, या तो आप रोड्रिक्स फॉर्मूला यूज कर लो और यूज कर लो जनरेट. लेट अस यूज द जनरेटिंग फंक्शन. What does generating function do? So I know that generating function generates my Legendre's polynomial of different orders, and this is my generating function, root over 1 minus 2xt plus t square. So if x is equal to 0, so if x is equal to 0, if I take x equal to 0, this will be 1 plus t square ki power minus of month, and it will be equivalent to writing n equal to 0 to infinity tn 0, and here you have t ki power. Is that clear?
Yeah.
Okay. On the left hand side, you will see that there are only terms. So I'll write on LHS, there will be terms in even powers of t. Even powers of t. Clearly? देखो इसका एक्सपेंशन करोगे तो क्या आएगा? ऐसा एक्सपेंशन आएगा इसका 1 minus 1 by 2 t square plus minus 1 by 2 minus 3 by 2 divided by 2 factorial t square का square t की पावर 4 so on and so forth, और एक आ जाएगा minus 1 by 2 cn की वजह मैं ऐसे लिख देता हूँ. ठीक है, ये समझ पा minus 1 by 2 n, इसका मतलब समझते हो, मतलब जैसे minus 1 by 2 1 का मतलब हो जाएगा, minus 1 by 2 n का मतलब क्या हो जाएगा, it will be equivalent to writing minus 1 by 2 minus 1 by 2 minus 1 minus 1 by 2 minus 2 dash 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 minus 1 by 2 minus n minus 1 divided by n factorial. इज दैट क्लियर? ये चीज समझ में आती है? मतलब जैसे तुम देख रहे हो यहाँ पर क्या है, -1/2 माइनस वन डिवाइडेड बाई 2 फैक्टोरियल। तो अगर यहाँ n है तो यहाँ डिवाइड n फैक्टोरियल से होगा, लेकिन ये लास्ट वाला जो टर्म है वहां पे -1/2 माइनस n माइनस वन आएगा। इज दैट क्लियर?
हाँ जी सर।
ठीक है। और यहाँ पे कुछ आएगा t की पावर 2n is equals to summation n equal to 0 to infinity. You have pn 0 and then you have t की power n. So obviously here only terms which are corresponding to even terms can be compared. So odd terms will not be there. So देखो, अगर इसका दोनों साइड एक्सपेंशन करोगे, इधर राइट हैंड साइड पे एक्सपेंशन करोगे तो क्या आएगा? जैसे p नॉट 0 किया t की पावर 0, फाइन, ये तो कंपेयर हो गया। बट p1 0 t की पावर 1, वहां पे टर्म ही नहीं है। ऐसे p2 0 t की पावर 2, देयर इज अ टर्म हियर। देन p3 0 t की पावर 3, देयर इज नो टर्म हियर on the left hand side. So in any case you can find that p2n plus 1 0 will always be equal to 0. Always remember this fact. Is that clear?
यस सर।
Okay. And what do you think your P2N 0 would be? तो इसको भी देख ही लेते हैं एक बार, ट्राई कर, इसी में शायद हम अटक गए थे लास्ट टाइम। What would be P2N 0? So if I just use this generating function, that would be easy to use. So 1 plus t square minus 1 by 2 is equivalent to writing summation n equal to 0 to infinity Pn 0 t की power n. So you can see that only even powers in t exist on LHS. On LHS. Is that clear?
यस सर।
ओके। सो इसी को क्या लिख सकते हैं? आई कैन राइट दिस एज समेशन। इसको चाहो तो k इक्वल टू 0 या n इक्वल टू 0 लिख दो फ्रॉम इन्फिनिटी, इसको p2n ही लिख दो, कोई दिक्कत। इज दैट क्लियर? तो यही तो दोनों साइड एक रह जाएंगे, बिकॉज p2n plus 1 is 0, सो फॉरगेट अबाउट इट। यहाँ पे क्या आएगा? 1 plus t स्क्वायर की पावर -1। इज दैट क्लियर? और ये t की पावर 2n का कोफिशिएंट यहाँ पर क्या है? t की पावर 2n का कोफिशिएंट आएगा p2n 0, और यहाँ पर p2n 0 क्या आएगा? इट विल बी सब टर्म्स होंगे आगे की तरफ। समझ पा रहे हो ना? देयर विल बी टर्म एंड देन देयर विल बी टर्म, लेकिन t की पावर 2n किसके कोरस्पॉन्डिंग होगा? इट विल बी कोरस्पॉन्डिंग टू 1/2n t की पावर 2। समझ पा रहे हो? मतलब इसका nth जो टर्म है, मतलब जब ये पावर n हो जाए
यस।
इसके ऊपर, जब इसकी पावर क्या हो जाए n, जब इसकी पावर n हो जाएगी तो -1/2n t की पावर 2n इज इक्वल टू, कुछ आगे टर्म्स होंगे, कुछ पीछे टर्म्स होंगे, आई एम नॉट कंसर्न। सो p2n 0 इज इक्वल टू -1/2n, like this. Is that clear? And this will be equal to what? So I'll write my p2n 0 would be -1/2n, and which is equal to -1/2, and then again -1/2 -1, then again -1/2 -2 dash dash -1/2 minus n minus 1 divided by n factorial. Are you getting ना? ये n minus 1 यहाँ पे क्यों है? तुम करके देखना। जो ये वाला सेकंड वाला है ना, देखो ये वाला, सो दिस टी स्क्वायर का स्क्वायर, तो यहाँ पे 2 दिख रहा है, लेकिन यहाँ क्या दिख रहा है? -1/2 -1/2 -1। -1 क्या होता है? 1 क्या होता है? 2 -1। सो अगर यहाँ टी की पावर 2 चल रहा है तो यहाँ 2 दिखेगा तुमको। सो ये देखो, यहाँ टी की पावर 2 की पावर 2, समझ पा रहे हो? टी की पावर 4 क्या होता है? टी की पावर 2 की पावर 2, हियर इज 2, हियर यू कैन सी -1/2 -1/2 -1, -3/2 क्या है? -1/2 -1। सिंपली हैव एक्सपेंडेड दिस, you can say the expansion for any general index. So for any rational index, the expansion behaves this way. Okay, is that clear?
यस सर।
Okay. So your P2n 0 would be equal to, मैं थोड़ा ध्यान से लिख लेता हूँ उसको, P2n 0 would be equal to writing, I think एक काम करते हैं ना, सबसे माइनस कॉमन ले लेते हैं, तो कितने माइनस आएंगे? This is how many brackets are these? If I take this also in bracket, I think there are n brackets from -1/2 -0, -1/2 -1, -1/2 -2, -1/2 minus n minus 1. So you have n brackets here. Is that clear? If I take minus minus common out, Bharat, yes or no?
हाँ जी सर।
Okay, and this is +1, and then this is 1/2 +2 dash 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 1/2 plus n minus 1 divided by n factorial. Is that clear? और इसी चीज को तुम लिखना चाहो तो कैसे लिख सकते हो, इसी चीज को मैं लिखना चाहता हूँ, आई कैन राइट, इसको थोड़ा उल्टा लिख लेते हैं, -1/2 की -1 की पावर n, एंड देन इसको उल्टा लिखते तो 1/2 प्लस n-1, देन 1/2 प्लस n-2, 1/2 प्लस n-3, dash dash dash, 1/2 plus 2, then 1/2 plus 1, and then 1/2 plus 0 divided by n factor. Is that clear? मतलब मैंने just उल्टा लिख दिया इसको,
yes sir.
है ना। और ये चीज किसके बराबर होगी, एज इफ, इसको थोड़ा सा मैथमेटिकली देखना, इसको कंपेयर कर लेना, आई थिंक आई एम लिविंग इट टू यू, ये इसके बराबर होगी 1/2 n-1, आई थिंक n करके देख लेना, दिस इज समथिंग दैट आई एम लिविंग इट टू यू, ठीक है। ठीक है, सो इट इज इक्वल टू राइटिंग -1 की पावर n, and then I can write n-1/2 n। देखो इसको करके देखोगे ना, 1/2 n-1 n, सेम जैसे मैंने पहले करा था ना, ये पूरी चीज आ जाएगी, दिस एंटायर थिंग वुड कम आउट। फर्स्ट टर्म क्या होगा, 1/2 n-1 -0, देन 1/2 n-1 -1। मैं समझाऊं ये चीज, ये कैसे लिखा, देखो हम क्या लिख रहे थे, -1/2 n, याद करो, दिस एंटायर थिंग कैन बी रिटन एज -1/2 -0, -1/2 -1, -1/2 -2 dash dash, -1/2 minus n-1 divided by n, isn't it? अब ये चीज ध्यान से देखना, इस चीज को देखो, ये चीज कैसे लिखी जा सकती है, 1/2 n-1 n, this can be written as 1/2 plus n-1 -0, then 1/2 plus n-1 -1, so this will be n-2, then 1/2 plus n-1 minus, इस तरीके से लास्ट क्लास क्या आएगा, 1/2 plus n-1 minus of n-, is that clear? Is that clear बेटा? ये जो चीज
Yes
तुम्हें दिख रही है इन कॉम्पैक्ट फॉर्म में रिटन इन दिस फैशन, इज सो दैट मतलब थोड़ा सा आसान दिखे तुम्हें। सो ओवरऑल तुम्हारा p2n 0 इस तरीके से लिखा जा सकता है, योर p2n 0 would be -1 by हाफ की -1 की पावर n, n minus 1/2 n। Is that clear or not clear?
yes sir.
Okay, and so this is your p2n, ठीक है। and sometimes in books you'll find this expression which is simplified and it is written in this form, so you'll find in this form also. So if you solve it up to some extent, you'll find this will be an answer to this. So I'm leaving this as an exercise to you, you try to do it, बस कुछ नहीं करना, जो अपन ने ऊपर किया है ना इसी को थोड़ा सॉल्व कर लेते, मतलब इसमें से 2 कॉमन लेते जाना, 2 2 2 2 2 2 2, इधर से कॉमन लिया, नीचे आएगा 2 की पावर n, then I think then things would be easy for you to identify. Okay, is that clear? ओके मतलब ये कर लेना, इसके आगे कुछ नहीं करना तुम्हें, यहाँ पे तुम ये 2 दिख रहा है ना, you just take this 2 common, so 2 2 2, all these 2's if you take common there will be 2 की पावर n नीचे की तरफ, and then you just try to play with these terms. If you play with these terms you'll get an answer to this, because this will be 2n minus 1, this will be plus 1, this will be 2n minus, देखो ना थोड़ा ध्यान से देख, मैं कर ही देता हूँ थोड़ा, तो इसको देखो मैं कर ही देता हूँ, so p2n 0 is equivalent to writing क्या था, -1 की पावर n, and then I think I had 1 plus 2 n minus 1, and then I had 1/2 plus n minus 2, then 1/2 plus n minus 3 dash dash dash, 1/2 plus 1, and then I had I think 1/2 plus 0, so I'll write 1/2 there only, and then I think there was some divided by n factor, right? So इसको थोड़ा अगर ढंग से सॉल्व करोगे तो क्या आएगा, -1 की पावर n की जगह -1 की पावर n आएगा, दिस विल बी 2n minus 1, थोड़ा ध्यान से देखो, 2n minus 2 plus 1, this will be 2n minus 3, then there will be 2n minus 5 dash dash, this will be 3 and then 1 divided by all these 2's. If you take तो यहाँ पे आएगा 2 की पावर n n फैक्टर. देखो यहाँ पे 2 है, यहाँ पर 2 है, यहाँ पर 2 है. If you take like LCM, so सबका LCM 2 ही आएगा. And how many brackets are these? These are n brackets. Remember, n minus 1, n minus 2, n minus 3, 1, and this is 0. So 0 से लेकर n minus 1, how many counts are there? N. So there are total in totality n brackets. Is that clear to you, beta? And what you can do, you just multiply. So, किस चीज की कमी दिख रही तुम्हें यहाँ पे? एक गलती हो रही है शायद, कुछ गलती करी है मैंने एक. चलो देखते हैं. आई थिंक देयर इज अ मिस्टेक. चलो देखते हैं. ठीक है, यहाँ तक ठीक है. 2n minus 1, 2n minus 3, 2n minus 5, 3 and 1. Is that clear? ऊपर वाला पोर्शन. मेरा तारे गेटिंग द पॉइंट. मतलब ये चीज समझ में आ रही है मैं क्या बोल रहा हूँ?
Yes, sir.
ओके. व्हाट शुड आई डू नाउ? थोड़ा सा देखना पड़ेगा. P2n 0. लास्ट टाइम इसमें फंस गए थे यार, वापस फंस रहे शायद. देखते हैं. सो व्हाट आई विल डू, I'll fill the spaces. So I'll fill the spaces मतलब मैं 2n से multiply करूंगा, 2n minus 1 रख दूंगा. So what I'll do, I'll write these terms in green. So I'll fill the spaces. So I'm filling the spaces. I'll write 2n minus 2. Then again I will write. Then again I will fill the space by 2n minus 4. समझ पा रहे हो मेरी बात? And there would be 2n minus. And then there would be a 5. I'll fill the space by 4 here. Then again 3. I'll fill the space by 2 here. And then 1. Divided by this whole divided by एक गलती हुई है. अब पता नहीं क्या गलती हुई है. This will be 2 की power n here. And this will be 2n into 2n minus 2. This will be 2n minus 4 dash dash 4 into 2. And then there will be n factor. Is that clear? I think
Yes,
this
sir.
should be somewhere 2 की. चलो देखते हैं, मैंने कुछ गलती करी होगी. चलो देखते हैं. I think this should be 2 की power 2n then. Because सब में से एक कॉमन आएगा ना. This should be 2 की power 2n. मतलब this expression should be 2 की power. चलो चेक कर लेते हैं एक बार. ठीक है, यहाँ तक समझ में आ गई बात? Then I'll write P2n 0 would be equivalent to writing minus 1 की power n. ऊपर वाला पूरा ब्रैकेट देखो. This is 2n का होल फैक्टोरियल मानते. डिवाइडेड बाय यहाँ से 2 कॉमन लो, यहाँ से 2 कॉमन, यहाँ से 2 कॉमन, सबसे 2 कॉमन ले लिया. सबसे 2 कॉमन लोगे, कितने 2s हैं ये? देखो ये 2n है और ये 2 into 1 है. तो 1 से लेकर n तक की गिनती कितनी होती है? 2 की पावर n. एक 2 की पावर n ऑलरेडी है और ये हो जाएगा n फैक्टोरियल और एक n फैक्टोरियल ऑलरेडी है. तो दिस विल बी n फैक्टोरियल का स्क्वायर. सो P2n 0 I can write as minus 1 की पावर n, 2n का होल फैक्टोरियल डिवाइडेड बाय 2 की पावर 2n एंड n फैक्टोरियल का होल स्क्वायर. आई थिंक दिस शुड बी 2 की पावर 2. ठीक है, सो इसको करेक्ट कर लें समवेयर यहाँ पे फॉर्मूला. ठीक है, इज दैट क्लियर?
Yes, sir.
Okay, so I hope like all these things are kind of facts only. So या तो तुम इसको एग्जाम के हिसाब से अगर पढ़ो तो याद ही कर लो, या फिर जो टेक्निक सिखाई है वही है कि जब भी क्वेश्चन एग्जाम में आए, try to put some values for n and then try to see which of the options are matching, because that is the best technique that you can do for exam. एग्जाम में इससे ज्यादा टाइम नहीं होगा तुम्हारे पास. Is that clear?
Yes, sir.
Just find me an integral. I'm giving you a question. Last question, or you can say last fact also, you can take it as fact number. What was the fact number going on? So all these are facts. Like मतलब ये चीज ऐसी है जो generally I cannot cover in the course itself. So I'm just covering it as a fact thing that you can remember. So this is, I think, fact number 6, or you can take question number 6, whichever way pleases you. Minus 1 to 1 pnx dx upon root over 1 minus 2xt plus t square. This value is equivalent to 2 की power tn upon 2n plus 1. How can you write that? Can you write this? Can you do this? So what I'll do, I know that my 1 upon root over 1 minus 2xt plus t square is the generating function for my Legendre's polynomial. So I'll simply write it as summation. Here n is there, so I'll write some other simple pmx t ki power m varying from 0 to infinity. Is that clear? So your left hand
Yes,
side,
sir.
I can write from -1 to +1 pnx, and then this sums is going over m
PM.
m equal to 0 to infinity. This is pm x tn tm dx. Is that clear?
Yes, sir.
And I know that this integration, but ये जो चल रहा है ये no doubt मतलब, so मैं ऐसा कह सकता हूँ sums m equal to 0 to infinity. In any case, this integration would go from -1 to 1 pnx pmx t की power m, and this is dx. Is that clear? So this will give you only non-zero integral if m is equal to what? N. Only if m equal to n, only then your integration would be non-zero. Otherwise, it will be 0. इसको एक्सपैंड करोगे तो तभी तो इंटीग्रेशन आएगा. मतलब इसको
Yes, sir.
एक्सपैंड करो तो ओनली इफ m इक्वल टू n, ओनली देन देयर विल बी सम नॉन जीरो वैल्यू. अदरवाइज यहाँ पर भी pmx है और यहाँ pnx है, इसको खोलोगे ना, इस ब्रैकेट को खोलोगे, अलग डिफरेंट डिफरेंट पावर्स ऑफ pm, डिफरेंट ऑर्डर्स ऑफ p0 जनरेट होंगे, p0 जनरेट होगा, देन p1 जनरेट होगा, t फिर p2 जनरेट होगा, t2, ऐसा करते करते देखेंगे कि pm t की पावर m आएगा, एंड देन देयर वुड बी pm t की पावर n इफ like n is greater than m. इस तरीके से कुछ आएगा. So only those terms where m is equal to n, only that will give you a non-zero term. Is that clear? So your integration on the left hand side, मैं इसको ऐसे कॉपी कर देता हूँ. This integration, I'm writing it here. Okay, this can be written as, this can be only having a non-zero answer if m is equal to n. That implies -1 to +1 t की power n dx, and this will be equal to what? pnx का whole square. And what this is, pnx का whole square dx. This t की power n तो पहले बाहर चला जाएगा because it has got nothing to do with the variable of integration is x, and this is t की power n. So you have pnx का whole square dx. So what it will be equals to 2 upon 2n plus 1.
Yes,
I
sir.
hope it is clear now. Okay. So all these things probably may be asked in the examination, so I did it. I think not much is left. Now I'm leaving it up to you to read some engineering mathematics textbooks, and if some notes you can take from there for some points that I've left, then it would be more than sufficient for your exam also and otherwise also. Okay. Is that clear?
Yes, sir.
We finished this Legendre's polynomial thing today. Okay. So we'll meet tomorrow. Okay.
सर कपल्ड ऑसिलेटर्स के क्वेश्चंस कहाँ से
Yeah.
करें या उसको नहीं करें एग्जाम पॉइंट ऑफ व्यू से
मैं
मतलब
वो एग्जाम के लिए इतना इंपॉर्टेंट नहीं, डोंट वरी, इसको छोड़ सकते
सर
हो
वैसे
जितना मैं.
इसकी एप्लीकेशन मैंने उसमें एक सॉलिड स्टेट सब्जेक्ट में देखी थी ये लैटिस वाइब्रेशंस
हाँ
एंड
हाँ बिल्कुल
समथिंग
बिल्कुल,
कपल
लैटिस वाइब्रेशन में भी दिखेगा तुमको, वेव इक्वेशन डिराइव करने में भी दिखेगा. That I'll do. मुझे एक दो
ओके
दिन और दे दो ना, एक दो दिन दे दूंगा तो मैं बता
जी सर
दूँ. ओके चलो.
ओके सर थैंक यू सर